9.8. Solve quadratic inequalities. So solving quadratic inequalities are very similar to solving rational inequality that we did in chapter 7. But however, it's much easier. Okay. So first what we want to do is we want to rewrite the quadratic inequality into this format. Everything on the left hand side is greater than, less than, greater than or equal to, less than or equal to, and then 0 on the other side. That's the format that we want. And then what we're going to do is we're going to, like before, we're going to try to find out the critical points. For the quadratic inequality, the critical points is the zeros of the quadratic expression. Okay. And then what we're going to do is we're going to use these critical points to divide it into intervals on a real number line. And then we test each interval to find out which part is our solution. So let's take a look at on example 1. So first, I need to make sure that everything on one side of inequality and then 0 on the other side. So therefore, I'm going to be subtracting 8 to both sides. So it'll be x squared plus 2x is minus 8 is greater than or equal to 0. Factor this out so that we can find out our critical points easily, which is x plus 4, x minus 2. So from here, I can see that what is my 0 is going to be. So when x plus 4 is equal to 0, that tells me my x is equal to negative 4. That's one of the 0. Right? And then another 0 is what? X minus 2 equal to 0. So x is equal to 2. So I got 2 zeros in this case. So now what we're going to do is we're going to use this 0 to break it into intervals on the real number line. So here's negative 4. Here's 2. Since the inequality is greater than or equal to, these zeros are a part of the solution, so it's inclusive. So I have interval 1, I have interval 2, I have interval 3. And we're going to pick a point on each interval and test it. Where are we testing? Into the inequality to see does it satisfy or not. So on interval 1, I will pick the number negative 5. On interval 2, I will pick the number 0, which is easier number. Right? And interval 3, I will pick the number 3. And then we're going to test it. So when I test it, I'm basically plugging in this number into this inequality to make it easier for me to compute. So when I plug it into the first factor, negative 5 plus 4, that is a negative number. And when I plug it into the second factor, it will be negative 5 minus 2, that will be negative 7. So negative number times a negative number, that gives me a positive number. And a positive number, it is equal greater than 0. So therefore, this interval is what? Good. Testing the second interval. If I plug in 0, 0 plus 4 is a positive number. And then when I plug it into the second factor, 0 minus 2 is a negative number. And we know that a positive number times a negative number, the result is a negative number. A negative number cannot be greater than 0. So therefore, this is not our solution. Lastly, testing the third interval. Since we picked 3, I substitute 3, right, for the x. So when I substitute on the first factor, 3 plus 4, that gives me 7. So this is a positive. Times with 3 minus 2. That is also a positive result. So Now we know that a positive number times a positive number is positive, which is greater than 0. So therefore, this portion, this interval is also a part of the solution. And we want to write our solutions in interval notations. So my interval notations, according to this real number line graph, that will become from negative infinity to negative 4 inclusive, union with inclusive 2 to positive infinity. And that will be my final answer. Moving on to the next example. So this example, the good thing is it's already helped you to put everything on one side and the other side is equal to 0. So factor it. So when I factor this, first I want to factor out the negative. So this will become negative x squared minus 2x minus 1 is greater than 0. Now I want to continue on this problem. And notice that this is not factorable. So what we need to do is we're going to have to use quadratic formula to find out where my zeros are. Right? So after we found out this is not factorable anymore, that's what we need to do. Okay? So to find out my 0, using the quadratic formula, which is going to be x is equal to minus b plus or minus square root of b squared minus 4 times a times c all over 2a. So this gives me 2 plus or minus square root of 4 plus 4 over 2, which is 2 plus or minus square root of 8 over 2. That is 2 plus or minus 2 square root of 2 when I simplify it over 2. So simplifying further, this will be 2 over 2 plus or minus 2 times square root of 2 over 2. Now we got our 0, which is going to be 1 plus or minus square root of 2. So using this, I'm going to break it into interval, which is two cases. 1 minus square root of 2. Using your calculator, that should give you approximate decimal number. You have to find the decimal number because that will help me to later on test the point easier. So 1 minus square root of 2, that is approximately negative 0.41. And then 1 plus square root of 2, that is approximately 2.41. Okay. So now, when we look at this, this inequality is strictly greater than, so therefore, it's going to be open circle, not inclusive. Open circle. Right? So, which help us to get interval 1, interval 2, and interval 3. And I'm going to pick a number from each interval and test it as before. So, on interval 1, I will pick, since it's, I will pick negative 1. And interval 2, I will pick 0 because a negative number and positive number perfectly okay pick 0. And interval 3, I will pick 3. Now we're going to test each interval. This time, we're going to test it in our original inequality. Okay? So using your calculator, that will be faster because you're going to have to like punch it in every single number and then test it. So when you plug it in, -1 into your original inequality formula, that will give me a negative result. Okay, that will give me a negative result. A negative number is not greater than 0, so therefore this is what? False. Then I substitute 0. When I substitute 0 into my original inequality, and that will give me positive number. Okay? I'm doing it mentally. You should write it out, because let me point it out right here. -0 squared plus 2 times 0 plus 1. When you simplify it, it will be what? +1. That's how I got a positive. If you substitute it -1, you will get, you will see that you will get the negative number. Okay. So now we know that a positive number is greater than 0, so therefore this is my what? Solution. This interval is my solution. Lastly, plug it in 3. So when I plug it in 3, that will give me a negative result. So this is not good. So finally from here, I got my solution, which is between 1 minus square root of 2 to 1 plus square root of 2. So 1 minus square root of 2 to 1 plus square root of 2, writing in interval notation. Since the endpoints are not inclusive, I have to use parentheses to indicate that. And that will be the end of this set. This problem. Next, solving this equation. And from here, I can see that it is not factorable. So therefore, like before, I'm going to have to find out my 0 by using quadratic formula. So it'll be x is equal to minus b plus or minus square root of b squared which is 3 squared minus 4 times a times c all over 2a. This gives me -3 plus or minus square root of 9 minus 12 over 2, which is -3 plus or minus square root of -3 over 2. Notice that under the square root is a negative. This indicates that you have what? Complex number. This means no real 0, because we cannot get a real number 0. So what does that mean? Okay, we're gonna have to go back to the graphing that we talked about before to interpret this problem. So when there is no 0, that means we don't have x-intercept. So the graph of the parabola is going to be either on the top of the x-axis or at the bottom of the x-axis. Since my leading coefficient is a +1, that means the graph must be opening upward. So therefore, it cannot be opening downward. If the graph is opening upward and above the x-axis, okay, all of the y values are positive, meaning the result coming out from this formula is always going to be positive. Therefore, my answer will be -infinity to +infinity, because all the x value will work in this case. And this concludes the final this session.